We have already seen how a Fibonacci function works, and many of you may have noticed that a lot of redundant calculation goes on in this function. For example, if you call this function using n equals to 5, then if this function is called with n equals to 5, then if case is not true, so it will go to the return clause and it will call f4. So f4 will in turn call f3, f3 will call f2, and in f2 for the first time the if case will be true, so it will return 1. Then f3 will call f1, which is 1 also, so both of these f1 and f2 will return 1, and f3 will calculate its value, which is 2. f3 will return 2 to f4, and f4 will call then f2, which is also a base case, so it will return 1. So f4 is 3, then f4 returns to f5, f5 then calls f3, and notice that we have already called f3 here, but we are calling it again, but we don't need to calculate f3 here once again. But notice that this function doesn't remember the value of f3, so it has forgotten that it already calculated the value of f3, so it will call f2 again and f1 again. Then from these values of f1 and f2, f3 will calculate its value once again, which is 2, so it will return to f5, which is 5. So here we calculated the value of f3 again, but we didn't need to do it because we already calculated the value of f3 before. So how do we stop this redundant calculation? So if we store these values of Fibonacci numbers in some array, for example a, so in a1, let's store the value of f1, which is 1. In a2, let's store the value of f2, so this is f1, this is f2, this is f3, so f3 will be stored in a3, which is 2. And in a4, let's store f4, which is 3, and so on. So if we have some sort of global array, then when we calculate the value of fn for the first time, then we can store the value of fn in an array. So now let's see how we can do this in this function. For example, this process is called memorization or memoization. I don't know why it is called memoization, but this is a popular term. And so let's say we have some global array called A. So if we call f4, f5, f3, so there are two types of memoization. One is recursive memoization, another is iterative memoization. So first we will see recursive memoization. So recursive memoization is done with a recursive function. So if we write the Fibonacci function once again, let's call it recursive Fibonacci. And so in this function, actually if we declare an array, all of its cells are initially 0. So after the value of the Fibonacci numbers are calculated, so if n equals to 1 or n equals to 2, so when we call this function with n equals to 1 or n equals to 2, we store the value of Fibonacci here in an. Else, if it is called with n greater than 2, then we store the value in this. So notice that the difference with this function with the previous function is, in the previous functions we just return these values, but in this function, before we are returning these values, we are storing it in an. So when the function ends, we just return this an. So still this doesn't this will not help us to reduce the complexity of this function unless we use this value which is stored. So how do we know that the value of fn is already calculated? So initially all of these arrays are 0. So if an is greater than 0, so we know that fn is already calculated. So if it is already calculated, let's just return it from here. So we don't need to do this whole computation once again. So if n is greater than 0, just return an. So if we use this function, let's see how it works. So we call this function with f5. F5 is calling f4. F4 is calling f3. F3 is calling f2. So f2 will return. So when you call f5, a5 is not calculated. So it will go to the if case, but n is not equal to 5. So it will go to the else case. So in the else case, it will call rf4. So if you call this function rf5, then rf5 will call rf4. Similarly, it will call rf3 and it will call rf2. So rf2, in rf2 when n equals to 2, so it will return 1. So then it will call rf1. Rf1 will also return 1. So before returning a rf1 or rf2, it stores the value in an. So when rf2 is returned, it stores the value in a2. So in a2 the value is stored, which is 1. Then we return rf1. Before returning rf1, you store the value of rf in a1. So after this has returned, we calculate the value of rf3, which is 2. So before returning the value of rf3 to rf4, we store the value of rf3 here in a3, which is 2. So then we return the value of rf3 to rf4. So then rf4 calls rf2. So rf2, in rf2 we already know that a2 is greater than 0 because it is calculated and it is 1. So we return the value from here. So rf returns 1. Then we calculate the value for rf4, which is 2 plus 1 equals to 3. So before returning this value to rf5, we store the value here in a4, which is 3. So then we return the value of rf4 to rf5. Then rf5 calls rf3. So even though it calls rf3 once again, but notice that since the value of rf3 is already calculated, so we'll find that a3 is greater than 0 because it is already 2. So since it is greater than 0, it will return from here. So rf3 will return 2. So then we calculate the value for rf5, which is 5. So we store the value of rf5 in a5, then return the value of rf5 to the user. So in this way, notice that we stop the recalculation of rf3. So rf3 is being called, but it is not being calculated twice. So in this way, using a recursive function and a global array, we can memorize the value of the Fibonacci function, Fibonacci values in AN. So in A1 we store F1, in A2 we store F2. So in this way, since we remember the value which is once calculated, so in the next time, when in the next time we call this Fn again, which is already calculated, we don't recalculate it twice. So we just return the value which is already stored. So this is called recursive memorization because we are using a recursive function here. And there is another type of memorization which is called iterative memorization. So in the iterative memorization, we don't use any sort of um, recursive function. So in this case too, we say we have a global array which is A. So initially all of these cells are 0, and we have A1 equals to 1, A2 equals to 1. Then we write this loop. Let's say we want to calculate the value of Fibonacci up to 46. So we just write this loop, and we're done. So let's see how this works. So no, for the ease of showing example, let's say we calculate the value of Fibonacci up to Fibonacci 5. So when I equals to 3, A3 equals to A2 plus A1, right? So A2 and A1 both are 1. So we have the value of A3 equals to 2. So since if we execute these two lines are executed before this for loop, so they already store 1 1 here. So after the first iteration of this for loop, we have that A3 equals to 2. So since we have found that A3 equals to 2, we can store the so it already gets stored in A3. So A3 equals to 2. In the next iteration, I equals to 4. So A4 equals to A3 plus A2. So which is 2 plus 1 and 3. So F4 equals to 3. Then in the last iteration, F5 equals to F4 plus A3. So which is okay, so we didn't store the value of F4 here, so let's store it. So F4 was stored 3 here. So F5 equals to 3 plus 2, which is 5, and it is stored in A5. So it is stored as 5. So in this way, we are calculating the value of each Fn using the previous two values. So if we run this function until f equals to 6, so f6 will be calculated by summing these two values, which is 3 and 5. So f6 will be 8. So notice that while calculating the value of f6, we didn't recalculate the value of f5 and f4. We just use the value stored in this array. So actually storing these calculated values in arrays are helping us to reduce the amount of calculation. So if we didn't store the value of f5 and f4 here, we would have to recalculate these values again and again. So by storing the values of Fibonacci numbers in arrays, we are reducing the number of calculations. So this process is called iterative memorization. It is called iterative because we are using iterating loops. So if we use loops to memorize recursive function, then uh, it is called iterative memorization. But if we use recursive functions to store the values of some recursive function, then it is called recursive memorization. So now let's see how in practice memorization reduces the number of calculations and the total amount of time it takes to calculate something. So let's go to NetBeans. So here we have the traditional most easy to write implementation of Fibonacci. This function doesn't remember the value of Fibonacci, and this is the Fibonacci function in which we are just memorizing the value of Fibonacci. So let's call it Fibonacci memorized. So, and this is the one which is iterative Fibonacci. So, and this is the global array. So in the main function, I have added this line. So it is the start time. It is the starting time when this main function starts running. Then we calculate Fibonacci and print it. Then in this line duration, we take the end time minus the start time. So we get the duration. So we get the runtime of this function, and then we print it. So here we are just so now since calcfib is the iterative implementation of Fibonacci, so let's first comment this and uncomment this line int x equals to fm45. So fm is the memorized version, so let's use the traditional version f45. So we want to calculate Fibonacci 45. So at first let's calculate the Fibonacci 45 using the traditional Fibonacci function. So if we run this function, let's see how much time it takes. So the first value is the Fibonacci number, and the second value is the number of nanoseconds it took. So this is a huge number, and it looks like it has taken almost 11 seconds to calculate the value of Fibonacci. So if we just change this function to fm, now let's see how much time it takes to calculate this Fibonacci value, f45. So it has almost instantly returned the value of Fibonacci. So notice that the value is calculated correctly, but notice that this is the number of nanoseconds it took. So it looks like it has almost reduced the number of nanoseconds by 10,000. So this is almost 10,000 times faster for Fibonacci 45. So if we want to calculate higher values of Fibonacci, we will notice that we will get a huge advantage. So memorization helps a lot, and since Fibonacci 45 is still a small value of Fibonacci, even in this case, this has reduced the number of nanoseconds by 10,000. So now let's see how much time it takes to calculate the value of Fibonacci using the iterative approach. So in this case, we have to print a45 because x is no longer available. So, and now let's see how much time it takes. So it also instantly returns. So actually the computational complexity of using the memorized Fibonacci and the iterative Fibonacci, they're almost the same. So both reduces the number of nanoseconds by 10,000s in the case of F45. So the larger the number of Fibonacci we're calculating, the more the advantage. So we have seen that by using memorization, we can reduce redundancy. So when does this sort of redundancy happens? So notice that in the factorial function, we only each recursive function only calls one recursive function, but in the Fibonacci function, each recursive function calls two different values to different recursive functions. So fn is calling fn minus 1 and fn minus 2. So when there are two chains of command, so in this case it can happen that we are doing the same amount of work in many many times. So in such cases we just have to use some 1D array or 2D array or 3D array to store the states of Fibonacci numbers, and then this way we can reduce the number of calculations, not the number of nanoseconds or the number of computational complexity in this way. So I would suggest all of you to use memorization, but memorization is not necessary for uh, exams. So when you write real life codes which are recursive and in which cases that there are a lot of possibility to uh, for a lot of redundant calculation to happen, in those cases you can use memorization.